Happy Friday, guys. We're going to be doing area again today. We are going to be looking at two shapes today instead of just one, and they are going to be triangles and trapezoids. So yesterday we did area of parallelograms, and we talked about the two parts you needed to identify on a parallelogram, and that was the base. That was the base and the height. So just like in a parallelogram, if you want to find the area of a triangle or a trapezoid, you need to identify these same two parts. And if you remember back to yesterday, we said the base and the height have to form a right angle when they touch each other. If there are two other lines or any other lines that are not meeting, making this right angle, then the line is not a base or a height. So the base and the height has to form a right angle. Now when you look at a trapezoid, this one is labeled B1 and B2. That's because a trapezoid actually has two bases. Not just one, but two. So you're going to be using the two bases on a trapezoid and the height. And it doesn't matter which base you use. You can use base 1 or base 2, but in each one of these areas where it connects with the height, you should be able to see a right angle. So let's try a couple of these. We'll do two each, and then you should have enough information to be successful in your homework. If you have your notes page, I'm going to find the area of triangle A and the area of triangle D. So the first thing I want to do is identify the base and the height. I want the two lines that are meeting to form a right angle. So if you guys could please color code these two lines, just like I do, any color you want. That is where I'm forming my right angle. Right in this corner, you can see where these two lines meet is a right angle. Now, this page doesn't tell you the dimensions of the two lines, but it's gridded, so you can just count it. So if I count the base, 1, 2, 3, 4, 5. The base is 5 units long. If I count the height, it's 1, 2, 3, 4, 5, 6. Not 5.5 because it takes up half of that box, but the length of that line is 6 units long. So to find the area of a triangle, it's very similar to the area of the parallelogram. We're going to do the base times the height. But a triangle is only half of a parallelogram. So at the end, because a triangle only takes up half as much space, you need to divide by 2. So I'm going to plug in my numbers now. The base was 5. The height was 6. And then at the end, because a triangle only takes up half as much space, I am going to divide by 2. 5 times 6 is 30. Then I'm going to divide by 2. 30 divided by 2 is 15. Well, I don't know. Let's pretend like these are centimeters. If it was measured in centimeters, I would put 15 centimeters. And then what is the extra thing we've been talking about this week that you have to put on any area answer? Hopefully you're saying you need the little squared exponent. You need a 2. So your final answer for the area of triangle A should be 15 square centimeters. Triangle B and C are very similar. They're just sideways or upside down, twisted like triangle A. So you would still do it the same way. When you look at triangle D or E or F, they are going to be a little bit different. So if I try to identify the base on triangle D, I've got this line going straight. It does not look like this side of the triangle or this side of the triangle makes a right angle where they meet on the base. So when this happens, you have to find the tallest point of the triangle and then draw a line straight down from that point. This is now going to be your height. If you think about when you measure your own height, you stand straight up against a wall and measure from the top of your head down to the floor. So that's similar to this. Find the tallest point of the triangle, draw a straight line down until it meets with the base. So now I'm just going to count these just like before. The base is 1, 2, 3, 4, 5, 6, 7, 8, 9. The base is 9 units. And the height is 1, 2, 3, 4, 5, 6. The height is 6 units tall. So just like on triangle A, to find the area, I'm going to do the base times the height. And because a triangle is only half as much space as a parallelogram, I'm going to do the last thing, divide by 2. If you plug in your numbers, the base is 9 times the height, which was 6, and then I would divide by 2. 9 times 6 is 54, and then I'm going to divide 54 by 2. If you're not sure about this one, 54 divided by 2, I could split this up and do 50 divided by 2, and then 4 divided by 2, and then add them together. When you finish, you should get 27, and again, if we pretended like these were centimeters, it would be 27 square centimeters. You have to put that little exponent on the end for all area answers. So on the back of your page is trapezoids. I'm going to do the first 2 examples for you, and then you should be good for your homework. If you remember earlier, we said trapezoids have 2 bases. So please go over the 2 bases, and then I want to find a line on this trapezoid that's going straight up and down to form a right angle. Because this one has 2 bases, we're going to have to combine them together to say how long the bases are in all. So if I count my units, 1, 2, 3, this base is 3. Now I need to count the other base, 1, 2. That base is worth 2. And then the height, which is your straight line going up and down, if I count that, I should get 1, 2. So my formula for area of a trapezoid, I've got to combine my bases together. That means add. I'm going to do one of the bases plus the second base, just like a triangle, multiply it times the height, and then last, divide by 2. Almost exactly like a triangle, except you just need to combine your 2 bases first, and then multiply by the height and divide by 2. So I'm going to plug in my numbers. Base 1 was 3. Base 2 was 2. Then the height was 2. And I'm going to divide by 2. So if I do order of operations, I should think about doing the parentheses first. 3 plus 2 is 5. Then the rest of the question says 5 times 2 divided by 2. Next thing I need to do is 5 times 2, which is 10, and then divided by 2. 10 divided by 2 is 5, so my final answer, the area of the first trapezoid is 5, and if those were centimeters, I would put 5 square centimeters. Okay? The most important part is you add the 2 bases together, because there are 2 of them, before you continue the rest of the equation. If we look over at example 2, I'm going to do the same thing. I'm going to identify the 2 bases, and I'm going to pick a line that goes straight up and down connecting the 2 bases together. Well, if you look at this trapezoid, it has a slanted line and a slanted line. This is not a right angle. This is not a right angle. So I'm going to have to draw in my own base. So I'm just going to pick a space anywhere in the middle of the trapezoid that goes straight up and down so that I get that right angle matching up with the bottom base and the top base. I'm going to count how many units long these 2 are. The bottom base is 1, 2, 3, 4, 5. The top base is 1, 2. And the height is 1, 2. So now I'm going to do the formula. area of a trapezoid, first I need to combine the bases. Then I'm going to multiply by the height. And then I'm going to divide by 2. Just like in a triangle, the only new part, again, adding the two bases together because there's 2 instead of just 1. When you plug in your numbers, the bottom base was 5 plus the top base was 2. Then multiply by the height, and in this one it's 2 units tall, and we always divide by 2 no matter what. Thinking back to order of operations, I should do the parentheses first. 5 plus 2 is 7. Then I'm going to write the rest of the equation down. Again, order of operations, between multiply or divide, you do whichever one comes first, and 7 times 2 comes first. So this would be 14 divided by 2. So in trapezoid number 2, the final area would be 7, and if these were centimeters, it would be 7 square centimeters. Always make sure you get that exponent for any area answers. So here is a picture of me with one of the presenters who I went to his workshop yesterday and today. His name is Todd Nessaloni. He is a 5th grade math teacher, and he does some really cool stuff in his class. So here's my 2 icons or emoji faces. I am super pumped and excited to try and learn some of the things he does in his class so I can incorporate them in our class, and hopefully that will happen super soon. It is again homework time. I've picked 4 new faces. Which one of these represents how you feel today? Are you needing to call a friend because you have no idea what to do? Are you happy because it's Friday and you're like, woohoo, have a great day? Are you like Moto and you're showing me your teeth and a super big smile? Or are you like this guy who's kind of halfway happy but his eyes are bugging out? Enjoy your Friday. I will see you guys on Monday. Have a great weekend.